Hi everyone, good morning. In this video, we will talk about the rational and irrational number. But before going to start, my name is Puneshwar Nikhade, and in this video, we are studying about class 8 mathematics, chapter number 1, rational and irrational number. Actually, what is a rational number and what is a irrational number? What are the differences between rational number and irrational number? We will discuss throughout the session. But listen, what is a rational number? The numbers. You have heard about the various types of a number. First one is you are known about the whole number, then natural number, then even number, then odd numbers. So these are the groups and all are belongs to the rational numbers. Oh my god, what is this? So we will going in a detail. So first one is the number of the form m by n are called as rational number. What is mean by m by n? All the numbers that we could represent that numbers in the m by n form means m is over here a digit that is 1 2 3 4 5 6 7 8 9. This whole number, that all numbers can come, and in the uh, following term the n, where we can write 1 2 3 4 5 6 7 8 9 10 at all. So all the digits can come in the place of m. All the digits can come in the place of a n whenever we have to represent the number in the form of a m by n, except n cannot be equal to 0. If n equal to 0, then this number can become irrational number. Okay, means of what? That all numbers that could be represented in the form of a m by n, that all numbers be called a rational number. What are the numbers that we cannot call a rational number? Those numbers which cannot represent in the form of a m by n. For example, if we calculate a number of a pi, this pi, we are considering its value as an irrational number. Why? Because pi is actually 22 by 7. We are representing this number as this, but actually what happens, this 22 by 7 is not a it's a approximate value, is not an exact value. So its value, when we will count 7 22, so what, 7 1 ja 7, 7 1 ja 7, 7 2 ja 14, 7 3 ja 21. Now remain 2. What we will give? Point. Then we will write 20. 7 2 ja 14. Then again 6. Then 7 7 9 ja 7 8 ja 56. Then we will write this. Then we will write 40. Okay, we will write 40. Then what? 7 5 ja 35. So this way this number will always be carry out, continue, and no result we will find the same numbers after the point term. No such pairs can be formed. So this number will not be stopped at any point. So we cannot represent this particular number in the form of a m by n. And so we called this particular number means 3.124 means a pi's term as rational number. So this is a irrational number. You get my point? So such numbers we cannot represent in the form of a m by n. That number we called irrational number. Okay. So you got the difference between rational number and irrational number. Rational numbers are such numbers we can represent in the form of a m by n, and that number which cannot represent in the form of a m by n, that we called irrational number. What we can say? Irrational number. But before going towards that, there are we have to, in this chapter we will discuss about in a detail about a rational number, and there are some of the groups that we could form using the rational numbers. First one is a representation of a rational number can be on the number line. So how to represent rational number on a number line? So what we are discussing about, how to represent rational numbers on number line. Can anyone say what is a number line? Can you say me? Can you answer that question? Ki what is a number line? Yes, exactly. You have answered that. What? Number line is a simple line where we are representing numbers. What? A line where we can represent a number. This line is called as number line. Now there are some set of rules that we have to discuss in this chapter. That is, if we have to represent a number line, then we always write 0 in the as a middle digit. What? 0 as a middle digit, and right of the 0. Which thing? Right of this 0 we will write whole positive numbers. Such numbers which are the positive integers that we write on the zeros right. Okay, then 3, then 4, up to nth term. But when we are going towards the left of the 0, then we will find -1, -2, -3, -4, and up to -n term, up to plus nth term. Have you get my point? You are getting my point? Yes, definitely. Now what? If you have to write the definition for negative integer, then what we will write? We can write the numbers can be represented on a number line at the left side of a number line. The numbers can be represented on the left side of a 0 on number line. Numbers can be represented on the left side of a 0 on the number line. That particular integer we call, that particular number we called a negative integers. What we said? Negative integers. So such integers which can be represented on the left side of 0 in number line, on number line is called negative integers. If you got the negative integers, then we could say the same definition for a positive integers also. But for that we have to change this left side by right side. Then what we can say? The numbers, such integers which can be represented on the right side. On which side? On the right side of 0. On the right side of the 0 on a number line is called positive integer. Which integer? Positive integer. So this type of there are two groups that we can form by the number lines right side and the left side. That two groups are, first group was positive integers, positive integers and second group we call negative integers. So first we have discussed about the how to represent rational numbers on number line. So this was our first point that we have discussed in a general way, in a detailed way. Okay, so I will remove this definition from here. Then we have studied two set of numbers, means a two group of a number. First group was integer. Which integer? Negative integer. Then second group was positive integer. Okay, there are two groups. First one is a negative integer and second one is a positive integer. And if we include this whole, then we could say these are the real numbers. What we can say? These are the real number. So real number have a two groups. First one is a rational, second one is a irrational. The numbers which can represent in the form of a m by n, that we will say the rational numbers, and those real numbers we cannot represent in the form of a m by n, that we call the irrational number. Then in a rational number we can create the two sets. First one is a positive integer, second one is a negative integer, and the term which is not a positive or not a negative, that is called a zero number. Which number? Zero number or a zero term. Okay, so real numbers or in a real what? Rational number can be formed three groups. First one is a negative, second one is a positive, and third one is a zero term. Then what if we are including zero? Which number? Zero in positive integers group, then we call this whole group as a whole number. Which number? Whole number. And the whole positive integer, which whole positive integers contains only number as a 1, 2, 3, 4, 5, 6, 7, 8, then we will got that numbers or digits or numbers created by that digit are the natural numbers. Which numbers? Natural numbers. If zero in a positive integers, then there are that are whole numbers. But if zero is not available there, only positive integers numbers are included, then we call it a natural number. Which number? Natural number. Now what we have to discuss? We have discussed all the things. Then we have discussed about the some of the groups. Then we will going towards the show on the number line. We have to represent this particular rational number on the number line, for which we have to create a particular number line, and how we will create that particular number line we have to see it now. So I have to represent this particular number. That number is a 3 by 2 and 5 by 2 on a number line. So what will draw? I will draw a number line. I will simply register a number. These whole are the positive numbers. So I will write it from the 0. So 0, -1, -2. These whole terms are going there and going like this. On the negative side, same on the positive side. 1, 2, then 3. Now what on the lower side, on the denominator side, I have given there is a number 2. So I will divide these whole numbers, means in 1 and 2 numbers in a 2 parts. 1, 2. Okay, in a 2 parts. So 3 up to 3 I will do what? In a 2 parts. So I could say 3.5 on this number line is going like this, then 3, then one line will come, and then 4, then 5, then it is like this. So I can say this particular number after 3, 0 to 3 there are some numbers, and I want a number between 3 and 2, so 3 and 0. So how I will do? I will cut this particular thing and this particular thing at the same time. I will find the middle of this. So I got this. So I will represent it like a 1.2, 1.5 as a 3/2 digit. Same thing if I have to do with the 5/2, then what I will do? I will same cross of 0 to 5, then this term, then this term, then this term, then what? Then this term, and I will got this. So this particular point at which we can represent 5/2. So this particular point showcase 5/2. If I will cut 5 in 2 parts, then I get this particular part and this particular part. So I can write 5/2 on a number line at this position. Same thing I could do with a -3/2. Okay, this term -3/2. So -3/2 here. Again 2 are given. So I will cut in a 2 parts. Okay, I have cut it in 2 parts. So I want a number which is exactly between 0 to 3. So what I will do? I will again place my fingers on this number line. First term, second term, third term, I got this particular term. So this particular term represent 3/2 in a 2 parts. Okay, 3 in a 2 parts. So what it will say? -3 in a 2 parts. So -3 in a 2 parts. So I will get this point as a -3/2. Half of -3. This whole term was a -3, and the half of -3 is represented by this number. You can again simply, it could be calculated as 3 divided by 2. 2 1 ja 2. Again you will get 1, and for this 1 it is less than 2. So you have to write a point on here. Then it will become a 10. Then 2 5s are 10. So you will get a value of 1.5. Now you will find 1.5 on this number line. So this term was a 1 and this term was a 2. So what? 1.2 is placed in between -1 and -2. So this point is represent as a -1/2, and -1/2 was a -3/2. So this was all the terms that we have represented whole numbers on the number line. Now you have two questions in a homework that you have to represent 7/5 on this number line, then -5/11/8 on this particular number line. So this was a session, and now second thing that we have to study about this is like a rank the number. Which number is greater or which number is a smaller is a ranking of a number. So how we can rank the particular number here, like a 1/2 or a 3/2? Which number is greater? Can you say 3/2 is greater than 1? Yes, you can definitely say yes. So you said 1 is less than 3/2. It is only you have to showcase less than. So 1 is less than 3/2. Now you have to showcase which number is less and which number is greater. So you got 9/5 and 3/2. You can say 9/5 is less than 3 by 2. Now you have two numbers. First one is a 7 by 4 and second one is a 9 by 3. You can say like this. Okay, this term is less than 9 by 3. Okay, we have to represent like this. But when we have to calculate whole the term, then what we can do is simply, if I am giving in one term, that is 3 by 2 and 4. Now 9 by 2 and 4 by 3. Now you can say this term is greater and this term is lower. Which term is greater and which term is lower in this case? Can you say? Because these are the just term, means their difference is very small. So you cannot say this term is a greater and this term is a smaller. For that you have to solve that particular term. So we will solve it like a 3 by 4 and 9 by 4. This is not the answer. I just written like that. We have to find which term is less and which term is a greater. By seeing here a 9, we just write it is a greater sign and it is a smaller side. But we have to showcase it like a, means there are terms present in the denominator also. So whenever the denominators are changes, the values also changes. So we have to find the answer of that. So 4 by 9, 4 to the 2 and 4 1 point. So this value come in 2, then 3 by 4. So 3 1 is 3 and here 3 1. So this value came in 2 point and this value come in 1 point. So 1 is always less than 2. So we can say this value is greater and this value is smaller. So you have to also represent, if the question asks as a rank the number, then you will give this particular sign as a less than or greater to in the middle of this particular things, and you can represent or showcase that particular thing is a greater or a smaller in a rank. Now this particular term, you can say which term is a smaller or a greater. You have to do that. For that you can write 7 divided by 4. So what? 4 1s are 4. Here comes 4, remain 3, and what? 4 3s are, means we have to write a point. 4 7s are 28. So here the value came is 1.7. Then we have to write 9 divided by 3. Then what? We can write like 3 3s are 9. 3 3s are 9 point. So this value came 3 and this value came 1.7. So what? We can say this 7 by 4 is less than 9 by 3. Just simply we have to represent like this. Then you can convert this particular rational number in the decimal form. How we will do that? We have to write like 37 9 divided by 37. We just place numerator here, denominator is here. Then what we will do? We will try to solve this. Now whenever you will solve, you have to find greater value in a numerator and smaller value in a denominator. But we can see 9 is a smaller as compared to 37, and we want numerator as a greater value and denominator as a smaller value. So we will put 0 here and giving a point. When we will add point, we got a right to write here a 0, 1 0 here. Now you can say 90 is a greater than 37, and you could count 37 up to 19. We want such a number which is less than 19 and come in the table of a 37. So we got a 37 into 2, that is a 74 term. So we got that particular thing, this particular rational number in the form of a decimal form, and that was 0.2. We can solve it further. Okay, we got here a value of a 16, and 16 cannot come in the term of a 37, but now as we have write in the point, we got a permission to write a 0 here, and all the points are 0, so it will definitely come down. So 37 and 160. Now we got a we have to count a table of a 37, that we could say the 37 into 3, 37 into 3. So 7 3s are 21, carry 2, 3 3s are 9, 9 plus 2, 9 plus 2, 11. But it is a one term, then we could add 37 into it, then also the values get lower as compared to it. So we got 148 as a fourth term of a 37. So we will write 37 4s are 148, and we will minus it as a 12. So these are the type of things where we can divide this term and we can found the rational number in the terms of a decimal. Why we said this particular term as a decimal term? Because we can find the point in between that particular thing. So whenever we can represent this term in the term of a point, this rational number in the term of a point in between the terms, then we said this particular number is in the decimal form. So you get understand the decimal form. So I have given some numbers here for your homework, so you can convert that particular rational number in the decimal form. Now for your fourth exercise, there is a question which is asked as to represent or showcase my under root of 3 in the under root of 3 on a number line. You got under root of 2 on that particular number line. So what you have to represent like this on the number line, so that you get under root of 2. But for that we have a process. We will write 0 here. Okay, 0 1 here, here is a 2, here is a 3. Now you got a particular thing that is compass, and you got here is a 1, here is a under root of 2 is showcase. Now what we will do, we will do under root of 2's line in, we will draw a vertical line on a under root of 2. Now we have a 1 centimeter given here, so we will point out 1 centimeter here. Which 1 centimeter up to here. Okay, 1 centimeter. This whole length is under root of 2 length, and this whole length is a 1 unit. Okay, you have to showcase under root of 3. Now what? You have a Pythagoras theorem. What Pythagoras theorem? Now it can become like this. It is like a triangle and 90 degrees triangle. So whenever 90 degrees triangle, this hypotenuse represent, now I will give the name A, B and C. So in hypotenuse term, what it will showcase? AC square is a square of digit AB square plus BC square. So what? It have to showcase under root of 2, because this particular value 0 to 1 is a under root of 1. I can write is as a under root of 1 square plus this BC value, this BC value, AB value as a under root of 2. This is under root of 2. What it is? It is under root of 2. So I can write at the place of a AB under root of 2. Okay. Now, as a BC value we have considered as a 1. So 1 is under root of 1. Okay. So we have a under root of 1 square. So this total value, under root and square get cancelled, under root and square get cancelled, it got a 3. So I can say AC square is under root of 3. Under root of 3. AC square is a 3. Now I can cancel out this square by this 3 if I will represent that particular term as a AC square equals to under root of 3 square. I have taken square also and under root also. Now I will cancel this square and this square. I will get AC as under root of 3. AC as under root of 3. So I can say this particular term, this particular range A to B as under root of 3. And if I have a compass, I could draw this under root of 3 on a number line at this particular point, and I can say this particular point is showcasing under root of 3. Okay, and you can know that under root of 4 is 2. So under root of 4 will be came here. So this particular value is came first as compared to under root of 4, come in a front as compared to under root of 4. So this was the full chapter of a rational and irrational number of class 8 subject mathematics we have studied in this particular class. If you have so you could cover all the this particular exercises, question 1 2 3 4 using this particular session. So today's session we have discussed about the rational and irrational number, where you have got the information about the definition of a rational number, definition of a irrational number. What is a rational and irrational number? If we could say or represent the number in the form of a m by n, then we will say it is a rational number. We cannot showcase if m by n, then we will say irrational number. Then what we have to do, how to represent numbers on a number line. So we have find numbers representing on a number line. We have represent number from -1 to 0 and 0 to +1 on a number line. Then we have find some of the sets or groups of a number that are come under the rational number. So we can